Hi everyone. Today we're going to learn a new topic, electricity and chemistry. So this is a very interesting topic that you're going to have three subtopics under this topic, which is electrolysis, electroplating, and extraction and manufacturing. Okay, so for today's lesson, we're going to look into electrolysis, some basic concept of it. So going here for electrolysis, this is what you need to know. Okay, you can see those learning outcome over here. For core, what we'll be focusing today is we'll be focusing on electrolysis. Okay, to define electrolysis as the breakdown of an ionic compound, molten or in aqueous solution by the passage of electricity. So we're going to describe the electrode products and the observation made during electrolysis between inert electrodes. Okay, there are some specific cases that we will look into, and then we'll also look into the general principle that metals or hydrogens are formed at the negative electrode and that non-metals are formed at the positive electrodes, and we're going to predict the products of electrolysis of a specified binary compound in the molten state. And also for supplement, we're going to look at describe electrolysis in terms of ion present and reaction at the electrodes in the example given. Okay, so to start, we're going to see what is the definition of electrolysis. So electrolysis is actually it's a breakdown of a compound. We're going to break down a compound by the use of electric current. Let's say I have a compound of sodium chloride. So I'm going to break down the sodium chloride into sodium and chlorine gas. Then I need electrolysis to do that. And same goes to another compound. Let's say I have lead bromide, and I want to break down lead bromide into lead and bromine gas. So this is also you need to do electrolysis. Okay, and electrolysis can only be done for aqueous solutions of ionic compound, okay, or molten ionic compound. So now what's the difference between molten and aqueous? Simply means if it is aqueous means there is presence of water. That's the meaning of aqueous. That means, example, I take 1 tablespoon of salt and then dissolve it in water, then I call it as an aqueous solution. When I dissolve something in water, then it becomes aqueous solution. And any ionic compound in solid state cannot conduct electricity. So we cannot electrolyze ionic compound that is in a solid state. Now why that happens? So I have a diagram over here. This one over here is ionic compound in solid state, and here it's either molten or aqueous solution. Now when they are in solid state, you can see that the ions are fixed in a regular pattern. So what happens here is the ions cannot move. They're not able to move in this case because they are quite held strongly together by strong attraction forces. But when they are in molten or aqueous state, then these ions over here are free to move. So when these ions are free to move, then they are able to carry some electrical charges and they can be a good electrical conductor. Okay, so that's the explanation why ionic compound can only conduct electricity when they are in the molten or aqueous state, and they cannot conduct electricity when they are in the solid state. Now some key terms that you need to know in this chapter is in electrolysis, I can maybe show you the diagram over here. You can see this is a basic setup of electrolysis cell. I need to have this one over here. You can see these two things. Okay, one, this and this. I call this as electrodes. Now, what are electrodes? Electrodes are rod of a metal, or it can also be a graphite, which allows electrical current to flow through, and then so that there is some passage of current from the solution to the electrodes. Okay, so that is why that's the purpose of electrodes over here. Then we're gonna have inside the beaker, we're gonna have electrolyte. Now, electrolyte can be any ionic compound that is in a molten or aqueous state. The purpose of electrolyte is to conduct electricity in the beaker, so there can be some chemical reactions happening over there. And then normally for electrolysis to happen, we need to have a power supply. It can be a direct power supply, or we can even use a battery over here. And as you know, in battery we will have a negative terminal and a positive terminal. The electrode that is connected to the negative terminal is called the cathode, and the electrode is connected to the positive terminal is called the anode. Okay, so you need to remember that. That's very important. And then in terms of our electrolytes, inside electrolytes you're going to have ions, and these ions can be broken down into two. You might have some positive ions, or you can even have some negative ions. Okay, so positive ions are what we call them as cations, and negative ions are anions. Example, if I have a molten sodium chloride solution, then inside this molten sodium chloride I will have the Na plus and Cl minus. So the Na plus is the cation and the Cl minus will be the anion. Okay, so what will these anions and cations do? Okay, so I've written here, you can see here, anion is attracted to the anode, whereas the cation will be attracted to the cathode. So that's what happened inside a electrolysis cell. Now, to remember this, you can use the term panic, which is positive is anode, negative is cathode. So that means in your electrolysis cell, if you have two electrodes, remember the one that is connected to the positive over here is the anode, and the one connected to the negative is the cathode. And another thing that you must remember here is, remember that cations are attracted to the cathode, and anions are always attracted to the anode. Okay, so that means when I have two ions inside here, the Na plus and the Cl minus, the Na plus, which is the positive charged ion, a cation will be attracted to the cathode, and an anion will be attracted to the anode. So this is what you need to know about some basic concepts of electrolysis. So it's very important for you to remember all these key terms over here. 1, 2, 3, 4, 5, 6. You need to remember the 6 key terms over here, so that you can later when we do some questions, then you know what is electrodes, what is cathodes, anions, and also cations. Okay, so what actually happens inside electrolysis cell? So once we can break an ionic compound into the ions, so for example here I have the Na plus and the Cl minus. So once the Na plus attracted to the cathode and the Cl minus attracted to the anode, there will be transfer of electrons that will be happening inside this electrolysis cell. And this transfer of electron actually happens from anode to cathode. Okay, so electrons flow from anode to cathode. Okay, electron flows from anode to cathode. It's very important to remember this. Electron flows from anode to cathode. Okay, so this flow of electrons, so that's why a battery is very important over here. The battery acts as a power source. At the same time, the battery will also act as a pump, so that it can continuously pump the electrons in the cell. Okay, so that's some basic concept about electrolysis. So for now, you have learned that electrolysis is a process that we do to break down a compound by the use of electrolysis. Okay, so the next thing you have learned till now is some key terms, and also we have also looked at a basic setup of electrolysis cell. Okay, now there will be one important question that I'm going to ask you now. If you see in this diagram, there are two electrodes. Okay, now most of the time the electrodes are made from graphite. Okay, so graphite. So the question here is, why graphite? So why are we using graphite and why are we not using any other metals? The reason is graphite. Okay, number one, graphite is a good electrical conductor. Okay, you can conduct electricity well. And number two, graphite is inert. Now, inert means the electrode will not react with the solution. Let's say in the solution here, I have the sodium ion and the chloride ion. The graphite will not react with the ions, because if they react, then it's going to disturb my electrolysis process, because there's a chance that you might get a new product during electrolysis. So we don't want that to happen. That's why it's very important to use an inert electrode during electrolysis. Okay, so these are some basic concepts about electrolysis that you need to know for today. So in the next lesson, okay, so we will go specifically into this electrolysis process. I mean, we'll be looking into some specific compounds, some molten or aqueous solutions, and then we're going to see what happens during electrolysis, how to predict the product of electrolysis, and then how to write the half cell equation. So that we'll be looking in our next lesson. So this is what we learned for today. So hope you can have a look on this and then do some questions to practice the concept that we have learned today. Thank you.